we have been exploring Abuse Windows Internals room of TryHackMe. This room has a prerequisite. Earlier, I made a video about another TryHackMe room called Windows Internals. So I highly recommend you to watch that whole video before continue to learn this abusing Windows internals. And in my previous video, in part 1, I have explained the concepts like process hollowing and shellcode injection. Now we are continue to learn the next method is high level thread hijacking or thread execution. And they broke this method into 10 steps. Let's see what are all those steps. The step 1 is locate and open a target process to control. They are locating the target process, a legitimate process often. And the second step is allocating memory region for the malicious code. Once they spotted the process, they have to allocate memory in that process in order to inject the malicious code. That is the step 2. And the third step is write malicious code to allocated memory. And first three steps are as same as the shellcode injection process steps. The fourth one is identify the thread ID of the target thread to hijack. Here they are identifying the thread ID and targeting specific thread. I have already explained in that Windows internals video, a process at least have one thread and it can have maximum number of threads actually. So here they are targeting only one thread and they are collecting the thread ID. They are identifying the thread ID. And the next step is open the target thread. So once they spotted the thread, they are opening the target thread and they make that thread, they are moving the thread to suspended state. So in process hollowing method, we were moving the entire process into suspended state, but here they are targeting a specific thread and moving that specific thread into suspended state. And the next step is obtain the thread context. This is the seventh step. And the eighth one is update the instruction pointer to the malicious code. So they are updating the instruction pointer to point the malicious code. And the ninth one is rewriting the target thread context. So this is the ninth step, the penultimate step. And the last one is resume the hijacked thread. So once they accomplished all those rewriting thing and all, they are finally resuming the hijacked thread. The thread that was suspended earlier, they are resuming it here. And they are also breaking these 10 steps in detail along with the code blocks. Let's see what are all those. The first three steps outlined in this technique following the same common steps as normal process injection. Actually, we have witnessed the same steps in shellcode injection. Now, moving down further, you can see this code block. The first one is open process, or creating a process. The spotting the process and opening the process. And it is not creating the process, it is spotting a legitimate ongoing process and it is simply opening that process and allocating the memory within that specific process. And here you can see, here they are defined the, here they have designed the, here they have designed, pardon me, here they have defined method H process and they have called that H process method here in virtual alloc ex because they are simply creating a memory space in this specific process that has already spotted. And they are also gaining the size of the shell code. They don't know the shell code, so here they are using the function size of in order to gain the size of the shell code. So based on the size of the shell code only, they will be allocating the memory. And moving further, writing process memory. Once they allocated the memory, they are writing the process memory, which means they are trying to inject some code into that memory we allocated in process. And here also they are using the size of shell code in order to know the exact size of the shell code. And moving down, once the initial steps are out of the way and our shell code is written to memory, we can move to step 4. So this is the step 4 now, and we need to begin the process of hijacking the process thread by identifying the thread ID. So as I said before, every process will have at least one thread and it can be multiple. So it has, I mean, the thread has to be identified. So they are identifying the thread id, and in order to do that, they are using three Windows API calls: create, to, help 32 snapshot, thread 32 first, thread 32 next. So these are the three Windows API calls. These API calls will collectively loop through a snapshot of a process and extend capabilities to enumerate process information. So these three Windows calls usually enumerating the process and collecting the informations related to threads. And moving to the next one, the same one here, they gave the code block here: create, to, help 32 snapshot. Actually they are taking snapshot of the specific process, and thread 32 first obtain the first thread of the snapshot, and here thread 32 next is to obtain the next thread. So this is how they will iterate, and they will try to find the suitable thread. And moving to the step 5, we have gathered all the required information in the structure pointer and can open the target thread. So once the thread has been identified, our role is to open the thread. In order to open the thread, they are using the Windows API call open thread, or I'm sorry, actually they are using both the Windows API calls. So here you can see the keyword with open thread with the thread entry 32 structure pointer. All right, here you can see the code block for this respective operation, and the code block, you can see, verifies both parent process IDs match. So they first verifies whether the parent process ID is same or not, and if it is same, it is getting into this loop. And h thread, here they are defining the thread and the method, I mean, sorry, it's a function open thread, they are opening the thread actually. And request all possible access, they are getting maximum rights on this thread. And what is false, child threads do not inherit parent threads handle. So this is the definition for this false. And thread entry, so here you can see the thread entry, the Windows 32 API call, and the thread 32 id, read thread id from thread entry 32 structure pointer. And finally they are breaking this loop. And moving to the next one, step 6, we must suspend the opened target thread. To suspend the thread, we can use suspend thread. As we have seen in the previous brief step definition, they have defined in the sixth step that the thread has to be suspended, the target thread. So in order to do that, they are using the Windows API call suspend thread. And here is the simple line: they are passing the argument h thread within the suspend thread function. And the step 7, we need to obtain the thread context to use in the upcoming API calls. And this is the step 7. This can be done using the get thread context. So here you can see the code block. Here actually they are getting the information about that thread. So that is all about get thread context. And moving to the 8th step, we need to overwrite RIP. If you have no idea about instruction pointer register, actually it is CPU registers. It is 64-bit register. So that is what they gave here. And the RIP register to point our malicious region of memory. So we need to override this RIP to point our malicious region of memory. So they are making this RIP, they are modifying this RIP register, and they are pointing to the malicious code. And if you are not familiar with the CPU registers, the same thing they explained here. In a nutshell, it controls the flow of the applications in the memory. To override the register, we can update the thread context for RIP. And here you can see the line points RIP to our malicious buffer allocation. Moving to the step 9, the context is updated and needs to be updated to the current thread context. And this can be easily done using set thread context. So once they found the get thread, the thread context using get thread context, they are setting the set thread context. Actually, they are trying to set the current context in that thread by using the specific Windows API call. And here you can see the code block, the same kind of code block here, and they are defining the context also. At the final step, now we can take the target thread out of the suspended state. So once everything is modified, once they define the target thread, they are taking the thread out of suspended state, and they are accomplishing it with the help of resume thread Windows API call. And here is the code block. And you can see in the above code blocks, it is only the syntax. There is not the detailed explanation. There is no further. There is not much detail. But however, it will give you a high level idea about each and every method that is involved in process hijacking or process injection, some process exploitation kind of things. Okay, now we can compile the above above code blocks. You can compile the above code blocks with further details, and you can make the executable file. So you can use those executable file in order to exploit the process. Now moving to the answers, the question answer section, and here they are, they gave the same kind of exercise once again, but this time we are going to use the executable thread injector.exe, and again we are going to pass the process ID, any process that belongs to the user thm-attacker. Now all we need is to spawn this specific machine. Now I spawn this machine, TryHackMe's machine, moving into that folder, injectors. This is where all those injection executables are present. And I can see the list of injectors here. And now all we need is thread injector now. And let's open the PowerShell. And I am moving to desktop and injector folder. Here I can witness that executables // thread injector. So that is the executable we want, and we need the process ID. And I'm right clicking, opening the task manager, giving more details, and in details tab I'll be able to witness the list of processes and its process ID and further details. And here I can see the username that is holding the process, the owner of the process. And here I can see the list of process that belongs to the user thm-attacker, and we need to get one of these process ID. I have tried few process IDs before, but none of the process IDs was working except this PowerShell process ID, and the PowerShell process ID is 4316. So let's try it. 4316. So after I tried to inject this process ID as an argument, I got the flag. Now all we need is to copy and paste the flag. Yeah, we got the flag now, and this is just an information. Closing it. Moving to the next topic, abusing DLLs. Let's see what we are getting here. What is the method we are going to learn? Yeah, and the method now here we are going to learn is DLL injection. Again, it's a high level explanation. So let's see what they gave. It involves 5 steps here. Locate target process to inject. As usual, they are locating the target process, and they are opening the target process, allocating memory region for malicious DLL. Same kind of step here, and writing malicious DLL to allocated memory. All right, and loading and executing the malicious DLL. Okay, instead of the shell code or a typical code block, they are injecting the DLL file into the process memory. That is the only difference between the DLL injection and shellcode injection. Okay, moving to the next one. Let's see what are all the steps. Really denotes. The details of the steps. Step 1, DLL injection. We must locate the target thread. So in order to locate the target thread, there are 3 Windows system calls. The first one is create to help 32 snapshot, process 32 first, process 32 next. I think it is the same system call that we have used in the previous method, thread hijacking. And here they are locating the target thread. And the definition given here, so they are getting the process ID first. Once they got the process ID, they are locating the thread within the process. And once it is done, they are obtaining the size of the structure, byte size of the structure with the help of this size of function. And process entry 32. Again, the same thing, and the process 32 first in order to spot the thread. And moving further, I can see a method, a function called string compare. They are comparing the string here. Compare two strings to determine if the process name matches. And once it is matches, it is getting into the loop and the process 32 next. They are obtaining the next process in this snapshot. All right. Now also they are getting the process ID. Moving to the step 2, after the process ID has been enumerated, we need to open the process. This can be accomplished with variety of Windows API calls. Here you can see multiple API calls. One is open process, we have already witnessed it. And the next two Windows API calls, get module handle, get process address, get proc address. And here you can see the code block, the open process. Here they are using the open process function, and they are using the specific code block to open a specific target process. And the step 3, memory must be allocated for the provided malicious DLL to reside. So like we have allocated the memory for the shell code in the shell code injection, we need to allocate memory for the malicious DLL that we are going to inject. And this can be accomplished with the same Windows system function, virtual alloc ex. And the virtual alloc ex is the function. Again, they are calling the parameters here, handle for the target process, string length. So we decided to inject the DLL into the target thread, right? So what we need to do, we need to into the target process, right? So what we need to do, we need to uh, find the size of the DLL. We have did the same during our previous methods. We have did this. We did the same thing during the previous exercises. We witnessed the some other special Windows calls in order to find the size of the code that we are going to inject. Like that, here they are using the strlen string length function in order to find the DLL path. And moving down, step 4, they need to write the malicious DLL into the allocated memory. So for that, they are using the write process memory. And a small change here, a small conflict here. I have explained wrongly. I was bad. The size of the DLL, actually it is not the size of the DLL, it is size of the DLL path. So that is what they are defining here. All right, moving to the next one, the same system call write process memory they are using, and they are calling these parameters within this write process memory. They are referring the process DL allocated memory and DL full path. Actually, they are mentioning the memory, and also they are mentioning the malicious DLL path here, path to the malicious DLL and byte size of the malicious DLL. So this is where they are defining the size of the malicious DLL. String length, yeah. Here they gave byte size of the malicious DLL. Here they gave size of the DLL path. A small conflict I can see here. If anyone know about this, you can feel free to inform. I think there is a difference here. They are adding the value 1 with this value, so I think that is the change that makes difference, I guess. All right, moving to the step 5, our malicious DLL is written to memory, and all we need to do is load and execute it. Once we have loaded the DLL into the memory, we need to execute it, right? In order to execute the DLL, they are using the load library system call. So this is one of the popular systems calls used by the popular malwares and imported from kernel 32 library. And once it is loaded, they are calling the create remote thread API call, and it can be used to execute. I explained during the initial time when I started this explaining the specific room. I explained that the threads are responsible for the process execution. So that is why they are calling this create remote thread in order to execute the memory, the content loaded into the memory. I mean the DLL, using the load library as the starting function. So here you can see the code block, load library. They are getting the process address and also the module handle. So they are getting the module handle and also they are loading the library API call to import. So as I said before, they are getting this load library function from this kernel 32 library. So that is what they are trying to get here. And remote thread handler. So here, I mean, this is where they are creating the remote thread. And in order to execute that code, that the DLL that they injected, and they are referring the process, H process it is, and DLL allocated memory pointed to the allocated memory region, and the load library pointed to the starting function. So this is the code blocks that all you, I mean, that you need to know. And you can compile this code block and you can make the DLL injector.exe file, and you can give the process ID as an argument, and you can finally try to leverage that specific process or exploit the specific process. The same kind of exercise, even this time we have got. Let's see what is the question. Identify a PID, process ID, and the name of the process running as THM attacker to target. Supply the name and malicious DLL found in the injectors directory as arguments to execute the DLL-injector.exe located in the injectors directory of the desktop. So there is a difference here. We need, I mean, we should not give the process ID alone. There is one other thing. Supply the name and malicious DLL found in the injectors directory. We have to find, I mean, we have to supply the name, also the malicious DLL we have found in the specific path of the desktop. So let's see that. Moving to that injector path, I can see a DLL called evil.dll, and we need to give this process name, I mean the DLL name, along with the name of the process. I think that is what we need to do. So let's try to do that. I am again moving to the desktop path, injectors path. I can see the DLL as well as the DLL injector.exe, calling that DLL injector.exe file with dot backward slash, and I need to mention the process ID of the PowerShell is nothing but 4308. So mentioning that 4308, and along with the DLL file name evil.dll. Let's give this. I made a mistake. Actually, we should not enter the process ID. We're supposed to enter the process name. That is what they gave here. All right. Now let's try to enter the process name instead of process ID. The same command, only the change is the name. PowerShell.exe. Gotcha. Now we got the flag. Okay. Yeah, that's the answer. And with this, we have completed the DLL injection as well. So in this video, we have witnessed the concepts like thread hijacking and DLL injection. In the next video, I'll be explaining the rest of the stuffs, I mean the remaining stuffs in this room. Until then, I'm signing off. Cheers and love you guys.